Okay, and finally, we're going to go ahead and go into our last video. So we have, I'm looking for solving a linear equation by graphing. So we're going to be graphing things and then being able to figure out where it crosses. So when we're solving, we're trying to find the root, we're trying to find the x-intercept, or we're trying to find the zeros. So those three terms that we can use when we're trying to solve a linear equation. So by graphing, it's the easier way to do it. Here is an equation that we have. So whenever we have an equation, what we want to do is we want to find it. We want to move everything to one side. So we're going to move everything to one side. Before we do that, we're going to try to make this easier. So to make this easier, I'm going to multiply by a common denominator. So I'm going to multiply by a common denominator. So I'm going to look at all the denominators here. This one is 9 over 1, so there I have a 1, minus 1/3, so I have a 3, to equal 7 over 1, so I have another 1. So my common denominator is 3. Okay, so I'm going to multiply everything by 3. So when I say I multiply everything, I mean I'm going to multiply everything. So put parentheses around the whole thing. I'm going to distribute it through. So 3 times 9 is 27. This 3 and this 3 cancel, so I just get x. I get 1x. I'll leave it as that. And then I get 7 times 3, which is 21. Then what I'm going to do is I'm going to subtract 27 because I want to get this x all by itself. So I get negative 1x equals negative 6 because one's positive, one's negative. So I subtract the numbers, keep the sign of the largest, which is negative. Then I'm going to divide both sides by negative 1. So I get x equals positive 6. So solving for this, I get x equals 6. So that's one way to do it. I can see that of solving it, but what I want to do is I actually want to just move everything over to one side. So that's one way to solve it. I want to do this instead. I'm going to leave it as this. Notice solving it is actually easier than graphing it, but that's okay. So we're going to see that that's going to be a 0 or the intercept or anything else that we can. So again, we want to move everything to one side. So I get 6 minus 1x equals 0. Now, when I get everything to one side, then I'm going to have y equals 6 minus 1x. So when I get it that way, I'm then going to graph it. Okay, so we can kind of see different values here as to what happens. And we can kind of get these particular values, kind of start understanding how these values work in this particular case. But to do that, what I need to do is I need to learn how to graph. So graphing is something that we look at here. I can pick some points and figure out what I want to do. So I'm going to create a table to graph. To graph a line, and how do I know this is a line? We learned this in an earlier section. Y is to the first power, x is to the first power. So what I'm going to do is I'm going to pick x is equal to 0. So if I plug in a 0 for x, I get y equals 6 minus 1 times 0, which is just 6. I'm going to then pick y is equal to 0. So then I get 0 equals 6 minus 1 times x. I'm going to add 1x to both sides. That way those cancel. And I want to make the x positive. I'm just making it so that the value in front of the x is positive. So I get 1x equals 6, or x just equals 6. So there are my 2 points. So that means I'm going to go up 6. So I have, in this case, when x is 0, y is 6. 1, 2, 3, 4, 5, 6. So I have a point all the way up here. My second one, I have 6, 0. So I have 1, 2, 3, 4, 5, 6. So I have another point over here. And since it's a line, all I need is 2 points. And I'm going to graph those, connect those together. So my line looks something like that. Sorry, I ran out of room here. So there's my line. And there's my x-intercept. There is my solution. Now, I'm never going to say that graphing is easier. Sometimes just figuring out the equation is just easier. Now, this one's a little harder. So we're going to have to figure out how to be able to graph this one next. And that's going to be the next problem. So where do we have it? We have it right there. Check our answer. We're good. And that's all we have for that one. Okay, let's move on to the next one. Okay, so the next one is a little bit harder. So on the next one, what I'm going to ask you to do is not to graph it by hand, but to graph it on Desmos. So we're going to start using some Desmos. We're going to figure it out. But before we do that, we have to move everything to one side. So we look at this equation. This equation's a little bit more complicated. We have a common denominator of 2 because this needs a 2, this needs a 1, right? That's really, in this particular case, that's really 2 over 1. And we have a 2 here. So my common denominator among all of them would be 2. So I'm going to multiply the whole thing by 2. So what I'm going to do is I'm going to multiply it by 2, multiply everything by 2. And when I multiply everything by 2, I get x squared, because this 2 cancels with that one. I multiply the next one, which is a negative 2. I multiply that one by 2. I get negative 4, and I get equals 3x. A lot easier if I have integers or whole numbers there, then I don't have to worry about it. I have to get everything to one side, so I need to move this over by subtracting 3x and subtracting 3x. Those cancel. I get x squared minus 3x minus 4 equals 0. And there's my equation. So what we're going to do is we're going to go over to Desmos and we're going to plug that in. So if I go over to desmos.com, and I want you to get used to doing stuff like this, I'm okay with you graphing it on this, especially if I'm not giving you the graph. So we're going to say y equals x squared minus 3x minus 4. That was the equation. So x squared minus 3x minus 4. So that's our y value. I usually do it in order of the highest power of the variable, which is x squared minus 3x minus 4. Notice it's in red, so we can see that it's in red. I can change this color by holding down the left key or holding it down. You notice then it'll give me different colors, and I can change the color if I need to. So x squared minus 3x minus 4, we can see that it crosses the x-axis at 2 points, negative 1 and positive 4. So it crosses at 2 different points. And let's go back over to our table here. So we can see that here. We can see that it says that it looks like that's the function. Did I do something wrong? Negative 3/2. Well, that's where I made a mistake. And this is why it's so important to check your work. That should be negative. That should be negative. That would be positive. That would be positive. That would be positive. And that makes a huge difference, right? So notice when I change that to a positive on Desmos, just going back and changing things, notice that it's positive 1 and negative 4. So it kind of reverses it. That's something that we're going to understand a little bit later and see why that actually happens that way when that value changes. So I have, in the first case, I have just 1x squared. Okay, so when you're doing this, you have to click in here. I'm just going to put in a 1. I'm going to accept that because that value should just be 1. If I come in here, I'm going to click on that one. This one should be positive 3. And my constant value should be negative 4. And I don't know why it didn't like that. We're going to figure that out here when we look at the answers. Oh, so they left it as 1/2, 3/2, and negative 2, but I changed mine to constants to make it easier. Notice if you multiply everything by 2, you get my answers that you have there. So it's actually correct. It's okay. So now the equation has 2 solutions. That's true. The function intersects the x-axis in two places. That means the same thing. -2 is a solution to the equation. Here's -2, so that's false. The function has two zeros, right? If we have two intercepts, we have two zeros. The function is linear. That's definitely not a line. -4 is a solution. Yes. The function has 1, 0. That's no. 1 is a solution of the equation, and that's yes. So those I can figure out, and those are what the answers are when we look at those, right? Okay, so we got all those correct. Okay, moving on to the next one. And it looks like we have two more. I'm going to go on to another video to do the last two problems.